Hello, my name is Jerry Kim, and today we will be talking about gyroscopic precession. If you're wondering what that is, follow me to my physics lab. Before I introduce you to gyroscopic precession, let me introduce you to angular momentum and torque. Right here, I have a wheel, and when I spin the wheel, it likes to keep rotating in that same direction the wheel was originally rotating in. But wait, what is direction? Because if you look at the wheel, right here, the wheel is moving south. And right here, the wheel is moving north, and every part of the wheel is moving in a different direction. So to describe the motion of the system, physicists decided to make one vector to describe all of these motions. And the way they find this vector is that the physicians curl their right hand in the same direction that this wheel is spinning, and their thumb shows the direction of the angular velocity and angular momentum. And the wheel will keep spinning along this axis without the presence of a force to rotate the object, which is called a torque. And if I try to move this object, you see, it's not so easy to change the orientation because the wheel wants to keep rotating in that same direction it was originally spinning in. And this torque, which is this force I used to rotate it, changes the direction of this angular momentum. And the way you find the direction that this torque points is that you curl your hand in the direction you're trying to rotate the wheel, which is down this way. And that means that the torque points away from me because my thumb points outwards. And you use the right hand rule again to find that torque. So now, what is precession? Well, precession is defined as the slow movement of the axis of a rotating body around a different axis called the precessional axis due to the presence of a torque. Let's see this definition in action. So what happens if I just let this wheel fall? Well, it falls straight down because there's gravity creates a downward force on the center of mass right here, and this causes the wheel to fall down. But there's also something else. The gravity exerts a torque, making the wheel rotate as it falls down. And if you look at the direction of the torque, the wheel rotates that way, which means using the right-hand rule, the torque points outwards. So what would happen if I were to spin the wheel? You know that a torque changes the direction of the angular momentum, so what would happen? Well, it rotates, it precesses, and that's because when we spin this wheel, we create this angular momentum that points to the right, but then we also have a torque pointing outwards, creating a new angular momentum, a resultant angular momentum that this wheel tries to rotate around to catch up to, and that is precession. Before I end this video, let me blow away your mind one more time with another demo. This is Euler's disk, precession in action. To show this, if you look at the disk, it's spinning around its center and the precessional axis denoted in blue. Wasn't that a shocking demo? Thanks for watching.